From Systems Engineering, Dr. Abbas.
All right, thank you very much. So imagine a team of robots that are coordinating with each other and sharing information to perform some sort of complicated tasks, such as they want to spread out in an unknown region and want to cover an entire region. To understand this coordination, let's focus on this green robot over here. It is collecting data from its nearby robots. Let's call them neighbors. And after collecting this data, it is aggregating this information to get a better sense of what these other robots are doing so that it can make informed decision and can make the correct action or the correct move. However, there's an issue over here. The issue is that some of these robots over here can be faulty, or even worse, they can be malicious, trying to inject an incorrect or false information. So what would be the consequence of that? The consequence would be this green robot would severely get a wrong aggregated result. And as a result, it would take an incorrect action. And consequently, the entire network would collapse. So the question is, how can this green robot can make or reliably aggregate its neighbors' information? All right. And to make this situation even worse, the challenge is that the green robot does not know who is the good neighbor and who is the bad neighbor. It cannot distinguish between the good and bad information. So the real fundamental challenge here is, how can this green robot reliably aggregate the information from all its neighbors without letting the bad information sneak into the system, and do so without having any knowledge of the good or bad neighbors, or where this bad information might be coming from. All right. So as you can imagine, that this kind of situation appears in every single distributed system. May it be a distributed optimization framework, maybe it be distributed computing system, smart grids, multi-robot systems. So wherever there's a networking phenomena and agents are collaborating to perform some task, this kind of situation happens. So in our lab, what we do is that we have developed these resilient aggregation schemes that are provably accurate, meaning that despite a large number of these bad information sources, we are confirming that we can aggregate the information in a correct manner. All right? And not only that, but we have shown that the aggregation schemes that we have developed are provably the best, meaning we cannot design any other aggregation schemes that can handle more number of bad adversaries. So we can achieve the limits of resilience through those kind of aggregation schemes. Moreover, our schemes can also deal with the noisy information. If this data is noisy, has a lot of noise, we can still do that. All right, so in another work, very simply, I have 10 seconds. So we also deal with something called graph machine learning. Assume that we have graph structured data. These can be proteins, and we want to classify them. What are good proteins from the bad proteins? How can we do that?
Thank you.
So we have worked on this graph machine.
Bioengineering, Dr. Feng.